Video, we're going to explore the differences between static and parametric features of both Revit and Dynamo. In Revit, examples of static features would be the typical geometry that we create sculpturally as designers, namely the walls, the roofs, floors. All of these things are built by us, and they stay like they were built by us until we specifically modify it otherwise. The parametric features that you would see in Revit would be something like a family, for example, a casework base cabinet. The parametric features of the casework base cabinet are built into reference lines or planes that define relationships from one of the elements in the model to the other elements of the model. So when we change, for example, the height of a base cabinet, the height or depth of the top drawer might stay the same, but the equal distribution of the drawers below will modify to the new height of the base cabinet overall. In Dynamo, what you'll find is that we have static data and parametric data. Static data is information that we feed in on a one-time basis. The parametric part comes into play when we develop an algorithm that further modifies geometry by a set of rules that we define. These can be automated and built off of previous relationships. In order to begin exploring Dynamo and the information that we can process into an algorithm, we have to first understand the types of information that it can read. In the Revit components, you have parameters that are built into your rooms, your sheets, your families, and these take different forms. In these examples, what you can see is that in the rooms and sheets, you have a series of textual as well as numeric data input. In family parameters, you can see that a lot of that information is also textual and numeric. Our first exercise within Dynamo is going to begin with textual data input, and those are called strings. Open up a fresh new file in Dynamo. We'll start this definition with a manual setting to the manual automatic toggle, and let's get to work. The component that we're going to use to produce or generate string information, so this is textual information that's read as text, would be string. So in the library, search for string. The string component is dropped in with a text box on the left-hand side and an output arrow on the right-hand side. We'll need two string components in order to complete a concatenate or concatenation, which will blend the two sentence fragments together into one complete sentence. In the first string component, we'll write the phrase, "the quick brown fox." In the second string component, we'll write the phrase, "jumps over the lazy dog." In order to blend these two sentences together, we'll need the component for concatenation, which is called string.concat. If you just search for string, you can see it down the list, or you could search for concat, and either one will produce the component you're looking for. The icon will say A, B, C in blue, and the title will say concat. When it's dropped in, you'll have a string 0 with a plus and a minus, and then a string on the output side. So the string 0 is the input. The plus and minus will increase or decrease the number of string inputs that it can receive, and then the string output will be the product of the blending of these two sentence fragments. So click on the plus sign once. In the first string input, click on the output of your quick brown fox sentence fragment and plug it into the string 0 input of string concat. In the second string component, this component will be plugged into the string 1 input of string.concat. The last component that I want to show you here for this exercise would be the watch node. The watch node, when you search for it in the library, is described as visualizing the output of the node. There are a couple of different ways of doing this. The watch node makes it readily available to you at all times. Bring the watch node next to the string.concat and connect the string output to the watch input. When you click the Run button next to Manual, you'll see that the two sentence fragments are concatenated or joined to create your complete sentence. The quick brown fox jumps over the lazy dog. The other way of revealing the output of a node is to hover over the gray line that's in the bottom right corner of the string.concat component, and you'll see that the sentence actually shows up below the component, but if you move your mouse away, it disappears. Once you hover over, there's a gray switch that appears on the right side of that sentence below the node. If you click that switch, it becomes a permanent display. If you click it again, it'll turn that display off and it'll hide it once more. Now, if you switch your automatic manual toggle over to automatic, we can make a change to the first string, and you'll see that that change is immediately propagated into the watch panel. In the string 0 input string, change it to read "Beauty is in the eye." Now you'll see that the watch node actually reads as "Beauty is in the eye, jumps over the lazy dog." We'll have to change the second string, so the string 1 input, to read "of the beholder" to complete the sentence "Beauty is in the eye of the beholder." Now that we have a firm understanding of automatic and manual data processing and a little bit about textual data input, we need to now look at numerical data input. We're going to do this by also exploring how geometry is published into Revit and why it's so important to begin with the end in mind. For example, if we need to create a curve in Dynamo and then publish that curve to Revit, we'll need the modelCurve.byCurve component. The description when you search for it in the library reads, "Construct a Revit model curve element from a curve." Now the subtext to this is that it understands a curve to be a Dynamo generated curve data point. Now if we work backwards, this component's structure reads that it has a model curve output and a curve input. Over time, we'll begin to understand more about the different types of geometry that can be converted to read as one another. In this particular case, we can give a line to the curve input, which will read as a curve. If you search for line in the library, you'll see that the first one is by start point endpoint. There are also a number of other different types of lines that we could be interested in, but the start point endpoint line is going to be the simplest for us. It also requires a numerical input in order to provide the location of the points that we need. So once that's in the workspace, we won't connect it yet. We'll also need to generate the location of points that we're going to create our line with. Just like we did in a previous video, the point.byCoordinates component is going to be the one we'll use. Search for point and bring in a byCoordinates point. It will require an X, a Y, and a Z numerical input, and it gives us a point output, which we can connect to the start point and the end point of the line. In this exercise, we're going to create our first point at the origin with a numerical input of 0, 0, 0, and the endpoint will be 10 units off of the origin along the x-axis. So our first point by coordinates will receive an x, y, and z input of 0, and our second by coordinates will receive a y and z input of 0, as well as an x input of 10. Using the numbers node, we can generate a numerical value of 0, as well as a numerical value of 10. Once the numerical inputs are connected to point.by coordinates, hit run. You'll see that in the background 3D display, the 2 points that we've generated now are shown in the Dynamo user interface background. Once we connect the start point and the end point, Dynamo reveals a line that connects the two. Now, this line does not yet exist in the Revit workspace until we have converted that line to a model curve using the model curve by curve component. So after we connect the line to the curve, hit run for a third time, and in the Revit workspace, we now have a model curve that's readily modifiable. The important thing to note with this is that this geometry is specifically tied to the Dynamo definition. If we select the model curve and move it away from its original position, the Dynamo line is shown, the model curve's new location is shown. However, if we run the Dynamo definition again, it'll return that model curve to its original position. If we delete that model curve and then run the Dynamo definition, it will also regenerate that model curve in its Dynamo-defined position. If Dynamo is running in automatic mode, you will be able to select the model curve in Revit, but once you move it or modify it or delete it in any way, it will automatically regenerate via Dynamo and return it to its original position. In this video, we've explored the differences between static and parametric features of Revit and Dynamo. We've looked at the different types of information that Dynamo can read from the Revit environment. We've explored textual data input via a concatenation. That also provided us knowledge in what the difference is between automatic and manual data processing. And we've explored the relationship between geometry that's generated in Dynamo and geometry that lives in Revit using numerical data inputs. And stepping back for a moment, overall in Module 1, what we've explored is that visual programming is a way for us to peek behind the curtain of the software package itself and provide more power for generating algorithmic relationships that enhance our usability of the software. We looked at other examples of software packages that utilize visual programming. We've refreshed ourselves in the Revit user interface and introduced ourselves to the Dynamo user interface and how it processes information. In the next module, entitled Basic Features of Dynamo Form Generation, we'll further expose ourselves to more nodes and components that can be used to generate more intriguing geometry. We'll learn more about file management, how to organize our files, how to write notes about our files, and how to generate more interesting and more complex algorithms for our designs. And very importantly, we'll look at lists and how data is passed through Dynamo at a higher level.